You make a bunch of noise out here, so they have peace and quiet in here. Because there's no better sound than the squeak-free guarantee from Advantech Subflooring and Advantech Subfloor Adhesive.
Pete Yost here for the UnBuild It podcast. I'm with my fellow casters, Jake Bruton and Steve Basic.
Hello.
Yo.
This topic came up in my head all by myself.
Hence why Pete's hosting.
Yeah. We'd like to talk to you about energy modeling. And I have flirted with actually doing energy modeling several times. And frankly, it's like going to the dentist for me. I really don't like to do modeling. Seems pretty tedious to me. And what I want to talk about with Jake and Steve, because of course Jake's a builder, Steve's an architect, and I do consulting. Where does energy modeling fit in our work for high performance? So let's just start right there, which is I'd like Steve for you to start. How does energy modeling fit in, if at all, with the work that you do to design buildings?
So I do it kicking and screaming. I don't do it. I detest, I should say.
Does your office do it?
No,
Okay.
not at all. And I will never, ever do it.
Boy, this is going to be
taking
quite
a
a
stance.
session.
Yeah.
So
it's just there's
you
other
do
people that
modeling, but not energy modeling.
There's other people that are just better at it, and I don't have an interest in sitting there and plugging in decimal places to get a number. But I mean, most of the projects we do, it's probably a requirement, right? Because if we're doing a passive house or some type of house for certification, we need it for that. If we're doing a house up in the Northeast, Massachusetts requires that we have
A HERS number?
HERS number, yeah.
Yeah.
A HERS rating and blower door, testing and all of that stuff. So we need it for that. Plus the homeowners that or clients that I'm working with, they like to have a number that they can talk about, right? Like if it's a zero energy or negative number on the HERS rating, then yeah, they walk around all proud about it, and that's good. So we do it. Probably the biggest problem I have is, and it's interesting because we come from the world of energy modeling, right? We used to, when I was at Building Science, I did do it with Phil. I forget the name of the program we used.
Well, there's Energy Gauge, which
That was the older one there.
It wasn't an abacus.
No, it wasn't an abacus.
No,
it
wasn't ResCheck?
It was ResCheck. No, it wasn't ResCheck. It wasn't ResCheck. I have to do ResCheck, but that's a joke.
Yeah.
Because I can fumble the numbers, and I can always. It's just a matter of, ResCheck is one of those things where you put in a bunch of square footages, you put in the R value, and then at the bottom it just says pass or fail.
Yeah.
And so I can sit there and say, okay, I'll do the calculation, and I'll have, say, 3,000 square feet of surface area and 250 square feet of windows. Mm-hmm. And it fails at whatever R value. But then I can just say, okay, 3,023 square feet and 247 square feet of windows. Still fails, but the number climbs. So then I say 3,030 feet and 242 feet of windows. Okay, now I pass.
Yeah.
There's not a building inspector in the country that's going to sit there and say, well, it's not 3,321 feet, it's 3,011 feet. So it's like, and I just say, well, okay, I made a mistake, whatever.
All right. So you brought up the first issue, which is you end up gaming the modeling as opposed to using it as a tool to improve the performance of the building.
Well, and if not gaming, it's still it's up to your input. Like, even if you're not doing it on purpose, we can't get our HVAC contractors to put in one ACH50 on a manual J.
Yeah.
And some of them don't even allow that, right? My understanding is like some HVAC guy says, I said, hey, we're going to build a really airtight building. He says, Steve, it's either, excellent, good, or average or whatever for airtightness. So there is no real spec. It's a 2 or 3 choices.
So full disclosure, we're talking about energy modeling, and none of us are proficient in energy modeling. But that's more by that may be a testament to whether we really need it to design and construct high performance buildings.
I think somebody needs to do it, because I don't think I care what my house is doing necessarily that I design, but I do care like what this assembly versus that assembly is doing.
Okay.
Right. So
There is knowledge to be gained.
there's
from
knowledge to be gained there, but I'm kind of like, okay, if I design this house and it has this assembly, and these are the choices for financial reasons for the builder, everybody like that, and we get back to the energy model, it kind of is what it is, right? And we can tweak it a little, but it's really not going to make that big of a difference. And some of it, I think, is that I'm bitter about is we've actually done some modeling and checked things, and it doesn't make sense. And then the industry is still pushing to do dumb things that when I use the energy modeling or the numbers to prove that it's a dumb thing, the industry is still saying, oh, you should do this. And I'll give that example. I don't know if you want me to do it right now, or if you want.
Sure. Yeah. Have at it.
All right. So you
Can I guess what the story's
and
about?
it's only 7:30. It's 7:30 in the morning, just so you know, and I'm already about to blast off.
Is this about over-insulating windows?
Yes, it is just. It is such a dumb idea. Now, if it's the only thing you did in a house, then it probably would shine, right? But we did a certified passive level house, triple glazed windows, the whole 9 yards, double framed wall, our like 60 wall, our 90 roof, crazy numbers. And the guy doing the modeling and the passive house consulting was the homeowner. He's a very intelligent engineer, went and took the course, became his own passive house
You're
consultant.
allowed to do it for yourself?
Yes. Well, you have to get it third party certified.
Okay.
But you can do the
You can
initial
punch in the
passive house
numbers.
and punch in the numbers, and so
Okay.
he did.
So
that.
that's interesting because you can use it as a tool, but then you have to have the final results.
Well, and that's what he did. He didn't
Yeah.
really trust
Yeah.
anybody, and he would sit at night and play with the dials.
Yeah.
Right, and that's what passive house is. You turn a bunch of dials and you do this.
Riveting.
And so we had something like 35 windows on this house, and the reality is that we already had the house down to, I don't know, it was like a $95 a month energy bill. Sorry, $95 a month energy bill, and it's like to over insulate the windows, it saved like $3 or something like that, right? And it's 35 windows. So then I actually went and I sat with the builder and said, like, give me a number here, right? The amount of foam we have to do, the amount of labor, et cetera, et cetera. So even at, say, a half hour of his time plus materials, it's probably $50 a window to over insulate it, times 35 windows. So that's like $1,700.
For a $36 a year savings. I just did the math.
A $36 a year savings.
Yeah.
Right. And and here's the thing. We did do it on that house. But I did it again, and we actually trapped the way they did it the second time. They trapped some water behind it, and I said we just never do it again.
Yeah.
Because it is just so risky that you can, because you're trying to solve for the worst control layer that we would agree on, right? Number 4 of the list, that we're creating a number 1 control layer problem.
Okay. So,
Water.
so
Water
this
management.
you brought up a second issue, which is whenever we look at just energy, oftentimes no good comes of that because that energy
Yes.
solution has to be related to the moisture solution. So that's the first problem for me with energy modeling is anytime you do anything in isolation, that's not how you integrate the performance of the building.
But I got to tell you, the story doesn't end there.
Uh-oh.
So, like, I don't know, maybe 6 months ago, I'm watching one of the evening group scenarios on the internet. It wasn't a BS and beer, but it was like that.
Okay.
So and they over-insulated the windows. Mm-hmm. The architect confessed to it was holding water. So their solution now was to go around to every window and drill like 3 holes
Pathways?
in the
Do we call 'em
over-insulated
pathways?
windows. And I was like, I was like my dad at home yelling at the Patriots on TV. Like, you guys are idiots. Just rip the foam off. Get rid of it. Stop. Just stop. Like, I think one of the problems with that world is that those people aren't necessarily as tuned to reality as they need to be, meaning construction. Right? It's easy to sit there and say, hey, I run these numbers. I'm a passive house consultant. You need to over-insulate the windows.
Yeah.
Okay, have you ever been out there?
Well, that's part of the disconnect, right? That's the disconnect for me. I think it's the same thing for you. Is like you get all these people saying these are the things that you're going to have to do, and not a single person that's ever said these are one of the things that you're going to have to do knows how to do the thing that they're asking us how to do.
Man,
that's a challenging aspect where it's like, yeah, but you have no idea how much that costs. It's on the 3rd floor on a walkout. Like, there's no way that they're going to be able to execute that detail. You're asking for things that aren't realistic.
It is a nuisance. Now, people are going to sit there and say, well, I've done it, and we've done it successfully. And that. Okay, so you save $2 a year. Good or $2 a month. Great, thanks. The guy can buy a candy bar. What was I going to say? Now you got me all.
Well,
sorry.
We can see your head's about to explode.
Yes.
So
Well, the whole like the reality thing. I was on a project. This was years ago, and there was this guy that he did all of my energy modeling, and he was let's call it. We had a required friendship. Okay. And
Does that mean passive
I
house?
hope to gosh that I'm not a required.
you're not a required friendship,
Okay,
right?
that's
It
really-
was like we had to be friends because I
You're an
needed things
incidental.
from him. He needed work. I gave him energy modeling. But man, this guy was a Monday morning quarterback. Every time we did something, it was, oh, you should have done this. It's like, you had the drawings for 3 months. Why didn't you make recommendations? And he wouldn't. He came out one day when we were installing windows. Oh, I'd like to come out and see that. So we're getting ready to install the window, and I look down at him, and I say his name, and I said, you know what? Why don't you install the window? And he says, what, you want me to do it? And I said, well, it's interesting because you're always telling me how to do things. It's like, what a great opportunity for me to learn from you. So why don't you get up here and do it? It took him like 2.5 hours. We did not. And he was fussing with it. You could see he was getting really frustrated.
But not admitting I don't know how to do
and not
this.
admitting how. And we ended up,
How
like,
tedious
the builder and I ended up finishing the window, and he backed down, and he didn't say anything, but I knew it was scrolling through his head, like, I get the point, Steve. That there's a slight difference between what I'm always kind of harping on and what it takes to do that.
Okay, so Jake, you haven't really weighed in here much, and I want to come back around on a couple things Steve said, but what does energy modeling mean to you? Who does it for you, if at all?
If I'm being honest, when we build in the city limits of Columbia, Missouri, we do have to get basically a HERS score to get a permit, and then we have to verify that score to get occupancy.
Wow, welcome to the 80s,
And
Columbia.
and you've just connected a rating or a certification number to some sort of modeling, but we don't know what that might entail.
But I always joke that, and I always lump Steve in with this too, that Steve and I do energy modeling, but we do it in real time at full scale. So we just build the house and see whether or not the house works. And it's worked really well to this point, at least. I'm with Steve on this. I understand the value that it provides to the industry. Somebody needs to figure these things out so that there's a trickle down from their computer software to some of the ways that we do things. I also, no offense, have not had an interesting conversation about energy modeling or Woofy models or Manual J's in which I came away feeling like the person talking to me about it knew how to do it better than I did, or not frustrated, where I was just like, yeah, but you live in your passive house tower and you think that the world revolves around your cult, and I just, you lose me.
So let's go back and start with Passive House because that came up, and the energy
Wait,
modeling.
you lose me. And I spent years in art school listening to hippies talk about how ethereal their picture of the sunset was, and I stuck with that. So that's like
You have a pretty high
I have
tolerance.
tolerance for idiocy.
Wow. I was expecting a little bit of moderation
No,
on this
I'm
topic,
gonna
but
take a hard
I have
line on
definitely
this
struck
one.
a nerve here. So let's take Passive House for example, because Passive House modeling is actually just a pretty big, complicated spreadsheet.
Yeah.
That's one thing. And there is modeling required now in the Passive House program, as I understand. You have to do a WOOFie analysis. Why was that added? Because just looking at energy performance resulted in some problems related to moisture, particularly in certain climates.
But here's sorry. Passive House shouldn't stick their nose into design. Okay? They shouldn't. I don't, I'll tell you why. I tell clients, they say, hey, do I want to do Passive House? And I was like, we can, if you want to, is my answer. And part of it
If
is
you're
because
excited about it.
they're going to tell me how to put the wall together. Right? It's like, no, that's my job. You know what? You have the air tightness standard, you have the energy standard. I'll meet those. And when I do, give me my certificate and go away.
Okay. So
I don't need you to tell me what type of material to use. I don't need you to tell me what type of wall assembly to use, where I should buy the material.
yeah.
No, shut up. You have your 2 requirements. I'll meet those. Give me my paper. I'll gladly go away.
So to be fair, I don't want to come off as we're, Debbie Downers on Passive House. Whenever we connect the modeling to a certification or a rating, to me, the benefit of those programs, and I think you'll agree, but I'm happy to hear you weigh in, is that they have helped change the way that our industry
I love
works.
the idea.
Absolutely.
I have the first passive houses in a number of states, the first passive house retrofit in the country. I just did the first passive house under the prescriptive program that we did that's a certified, and I can show you the email where the client said, I would never have done this had I known what I had to go through at the end of the project. Because there's so many people involved, they all have an agenda, they all have an interest, and it's not a straight line. It's this big wavy line, because now we have to do what John says, now we have to do what Bill says, now we have to do what Sally says. And by the time we get to the end, we've wasted a whole bunch of time, and it's a nightmare.
Okay, so let's go back to a program that requires modeling like Passive House. Does it require that you verify the rating and the modeling with actual performance over at least one annual cycle? Does the Passive House program say,
I actually
hey,
don't know the answer to that. I think it is just the upfront, and then you get certified before you move
Yeah,
in.
I believe so. I don't think there's a check on that. You get the certification based on the
It's a
third-party
predicted-
initial.
well, because there
testing.
are programs in the United States where
Yeah.
until you show that your building performed the way that you thought it would, you don't get your certification. And so you said we do modeling all the time, but on a real-time, full scale. I mean, that's the way that we should verify. So this, one of the things for me is it's modeling. It is inherently not real.
It gets me in the arena, right?
Right, but what we need is a feedback loop, right? So if we find that the actual performance of homes never meets what is modeled, and it's always because of the treatment of one particular facet, okay, well, that's helpful because now we can go back and make sure the model
I get that.
responds
The
to that.
problem with that is when I'm thinking about the number of passive houses that I've done, right? There's one, it's a retired couple. Like, their energy use is minimal, right? They wake up at 7 a.m., they go to bed at 8:30 p.m. The house is, they set it and forget it. But that's different than the other passive house that I did that has 3 young kids. They're more active. The dad stays up later. And they hang out their laundry. She didn't even have a dryer in the house.
Right.
And so there's a lot of things. So you can get that feedback loop. But the damn thing is so varied that I don't think you're going to get. Because the problem is that passive house whittles that energy number down to a very deliberate number, right? And that very deliberate number is deliberately tuned now to what the homeowners are doing. So the slightest change changes that number.
So let's talk about my house then, real quick. Like the first year and a half to 2 years that we're in my house met passive house levels of, kilowatt hours per square foot usage of electricity. Well, we have a home office. Our staff has grown. So there's more people, more monitors, more computers. We've had quite a few more guests over the last year. Like we've had people staying with us for like what feels like a week and a half or 2 weeks out of every month, be it one of you guys or our office manager stayed with us for 3 weeks while her roommate had COVID. Like there's all these little, our load has increased. We bought an indoor garden that has lights that are on for a good chunk of the day, 2/3 of the day. My wife, at the very end of COVID panic, bought a couple standalone air cleaners that are the worst for electricity usage.
And they're 24/7.
And they never turn off. And then she put one next to the rabbit's cage, and it's always on a red light showing that the air quality's bad, which is the reason to put it next to that. But it also means
farting bunny?
Yeah, we do. But like over the last year, our energy usage has left that realm of what passive house would allow.
Okay, well, so this brings
but our
up,
house would have qualified.
Yeah. So this brings up another issue, which is the modeling is only as good as the information going in. And if you design homes where you have really, really honed down the energy consumption that's related to the enclosure and the mechanical systems, because that's what we're good at. We're architects, engineers, builders. But when you take those loads and crush them down, all the other loads that are dependent upon occupancy behavior and number, appliances, plug load, lighting, and domestic hot water, they get bigger in proportion. And wait a minute, you're going to not take into consideration that there are 5 people that are 3 are homeschooled, 2 work at home. Shouldn't that be a different metric than for a retired couple that doesn't?
Or your family.
The retired coupled house. He's a retired engineer. He measures everything. Yeah. Right. We have current measuring devices on all of the lines.
Is that the one in Falmouth?
Yeah.
Okay.
Do you know what the biggest offender in his house is?
Oh, I'd love to hear this.
Take a guess.
The refrigerator?
It uses the most energy and it creates the most heat. The cable box.
Yeah. Those bloody suckers get...
He measured it. It's like 2.5x of the refrigerator.
Well, what we should do is...
energy this thing uses.
We should put bread grilling above that, and then we can eliminate the toaster.
But the idea is if you were in a house like this other family that I did, they don't have a TV in the house. So they don't have a cable box. So it's right there, the energy model changes rather significantly because you took the biggest offender out.
Okay, so this gets back to the other thing about modeling that kind of drives me nuts, which is you can have a model that just
has... Come on, join in. Jump in the pool. Come on, we want to hear it. You're being too politically nice.
You can have really, really simple models that have lots of gross assumptions built into them, but they're fast and they're inexpensive.
Yes.
The most sophisticated modeling program that we have for residential single-family buildings is BEopt. It's the Building Energy Optimization Program.
Did you say it's the most intricate or the easiest to use?
It's the most intricate.
Okay. So that would be the go-to if you wanted probably the best possible answer.
And here's why. This program was created by the National Renewable Energy Lab, NREL, to make sure that all the homes under the Building America program were using the same system to analyze the performance of their buildings. Because there were, 10 different teams at the heyday, and they were all using different modeling programs to come up with their solution. So NREL said, no, we're going to develop a pretty sophisticated program that all of you will use. And then at the end of that, they said, we've just spent a lot of time and money on a really good program. There used to be an hourly modeling program that you could purchase from the, now I'm not going to remember, but there was a solar-driven program that had an hourly modeling program that was good for buildings under 10,000 square feet. But that disappeared. So now NREL is the only hourly program that does this. So my point is that these programs are free only because the federal government developed them, but they're time consuming. You know, you can't have a much more sophisticated program and not have it be more intricate and take longer to do the optimization. But the cool thing about this for the Building America program was they used that to then compare to the actual performance of the buildings. And then that feedback loop improved the way that the program worked. But the other cool thing about the BEopt program is it's an optimization program. So you can tell it, okay, I want you to tell me what the optimal answer is, all the way down to where the last dollar that is cost effective on the enclosure tells me when to start putting PV on. So the whole reason for this modeling program was to allow you to take more loads and how they're created into the equation, but to get you at the point climate-based that tells you what the tipping point was for now you should spend your first dollar on renewable energy. And because it's an hourly modeling program, you know, there's 8,760 hours in a year, it allows you to take into account,
Just pulled that out of...
you know, how the sun's hitting the building. Because all the programs you've been talking about, they don't have the capacity to take the weather file and then tune it in at the level of the hourly performance of the building. Most of the real simple programs, they're just using monthly averages or daily averages.
Well, and that the weather profile, like if I built a house in the 70s, the weather profile in the 70s is not the same weather profile of the last 10 years.
Well, that's another big issue is the 30-year
Right.
average that you use. Yeah.
Yeah. And I don't know if you're ready, but I want to take this into the mystery world.
Ooh, we're going to get mystical?
We're going to get mystical here because
Not what I expected for energy modeling.
well, this is the other reason. Like I appreciate energy models. I don't want anybody to make a mistake and think I don't like it, don't appreciate it.
Yeah.
Go do it, get the numbers, figure it out, give me the numbers, and then leave me the hell alone to do my job. Don't insert yourself into my work. I don't go in there and say, hey, let's check your numbers on your energy model. No, I leave you the hell alone, do your thing, give me the numbers, and then let me do my thing. But here's where I think there's another problem with energy modeling. In my 30 years, I have done some pretty dumb things, right? We are
I could see that.
eager, enthusiastic young architect that says, oh yeah, let's do this. So if I told you, and you have run Woofy, and I believe you fully understand it, but if I said, hey, here's a 3,500 square foot house, it's in a location where the heating degree days exceed 6,800. And for the roof assembly, we're going to frame it with 2x10s and fill it with 9 inches of Icynene or open cell. What would you say to that?
In climate zone 6, approximately?
It's 5.
5.
Yeah, it's 5 mountains, kind of. It's Western Mass up in the mountains.
I'm going to really annoy you right now, I think. I never had any confidence in Woofy results for roofs in cold climates.
Okay.
And do you want to know why?
No, but okay, so let me rephrase that. Now, I don't really care what you think. What do you think the typical Woofy modeler would say to that scenario?
That's a bad idea.
They'd say it's a bad idea. The bottom of that sheathing is going to be wet as hell in no time. It was a friend's house. We did it. The first 3 or 4. You've been to that house.
I have.
And we've cut holes
through the
open
Icynene.
cell. We had never even found the slightest evidence of dampness.
Yeah.
The sheathing was dry as a bone. The house has been up now for probably 25 years.
Yeah.
And has never had a problem. But if I gave that to 10 Woofy modelers, I would guess almost 10 of them would say, don't do that.
Okay. So I want to come back to why I don't model roofs with Woofy, but that there needs to be a feedback loop to that modeling program about all the ways in which you didn't catch what was really going on with that roof. And there's so many conditions that are going to contribute to whether that moisture accumulates at the sheathing, like what did you assume for the interior relative humidity for the winter? You know, in that house, because of the occupant density, my memory is it was quite low.
It was 4 people.
4 people.
So
and it was
it's like 4 people, so that's like 800 square feet a person.
But you'd have to go back into woofy. So here's the other thing about modeling to me, which is the most important way that it's useful is sensitivity analysis, right? Because what you need to do is play with it to see if the perturbation that you gave leads to a logical result.
Lost me on that one.
The change, the small change that you're
Didn't say
doing.
change.
I don't know. I like that word perturbation because it's just
Sounds
All right.
filthy.
So you ready
That's why I
for
like-
mystery number 2?
okay. I
So
am.
mystery number 2. I designed the first passive house. We
the
did
first passive house?
that I designed.
Okay.
12-inch wall. We flashed the outside with 2 inches of closed cell, filled the rest with fiberglass, 10 inches. And it got certified. Like 2 years later, I'm doing literally another passive house down the street from this house. We submit the drawings. It was almost this. I probably copied the detail. Oh, you can't do that. You need 4 inches of closed cell. It's like, well, 2 years ago you certified a house with this. Oh, but yeah, we've understood it a little more. We've ran woofy, we've done this and that, and you can't do that anymore. You need 5 inches of closed cell minimum, or 4 inches minimum.
And is this
So they
after or
doubled
before
it.
they did woofy passive?
This is probably right on the cusp
Yeah.
of it coming out. But they made us do 4 inches there. But my point is now I look at them and say, okay, you want to play the governing body and you don't even know how to govern, because 2 years later you're making me do twice as much of what you said I could do. But here's the reality. We actually renovated and did some work on the one that had the 2 inches of closed cell in the wall. It was dry as a bone,
Yeah.
right? It didn't have any problems. Now, I come also from the world that we lived on doing building investigations, so I understand. There's some problems.
Right.
Things happen, and things fall apart, and people do dumb things and get caught doing dumb
Yeah.
things. I'm very fortunate that these two things didn't lead to failure. They led to success. But my point is that as an energy modeler, and we've met some that think like that is it. Like we're carving this in the slate, right?
Yeah.
It's the third tablet, right?
Yeah, they
And-
believe the only way for us to be successful as builders if they've run a model before we start building.
And when I talk to them about these kinds of scenarios, they're like, well, it depends on what got put in and this and that. The last thought I'll leave you with is if we had 10 energy modelers and I gave them a set of plans, I don't think more than 2 of the numbers would be within 10% of each other.
Well, that I don't know if that's true, but that is another scary thing, is that if you can run the model with different folks and get significantly different results, and it's, what did they use as defaults compared to what did they put in as a number that could change? So if you're using a model and you're not doing multiple runs sensitivity analysis, which costs more money, then you don't have a sense of what you're doing, whether it makes much sense. But I just want to come back to why I don't do woofy in cold climates on roofs. Because I asked one of the developers of the program, what about the snow load? Doesn't that have a significant impact on the thermal performance of the roof? Yeah, that would. And I said, there's nothing in woofy that shows what you assume or allow for the average snow load, much less what the daily snow load is. Well, if you want to do that, you'd have to develop a separate little mini program and then plug it into woofy. And I thought, okay, so I
You're
can't.
telling me your program doesn't work.
For roofs and cold climates, I don't think it does, because it's not a true hygrothermal representation. So this kind of stuff comes up all the time, as to how much is the model really helping us understand what's going on with the building.
The one that baffles me is if you go below grade and people do external insulation. And if I ask this question, I've never gotten an answer. What if you have a high water table and the water goes around that insulation and it's highly conductive?
Yeah.
Right? Is that insulation, do you degrade the value of that insulation because it's sitting in a pond of water adjacent to the foundation wall?
Well, my understanding is that there was efforts at ORNL to develop a below-grade woofy, and I just thought, man, ground coupling is incredibly complicated, and moisture
and it's
content
totally
in the soil.
is there standing water in the ground? Is it dry sand?
Yeah, it's And this is one of the reasons, frankly, why ground source heat pump loops are really difficult to understand about the heat exchange, because you have to make assumptions about the moisture content of the soil, and that's really complex when you don't know how it changes. And here's the last sort of issue.
Blast.
Yeah. I was talking to somebody about why you can't use DOE weather files for WIFI analysis. And it turns out that when they were taking the hourly weather data from airports for Energy Plus, which is the engine for all of the hourly modeling, the energy folks said, hey, there's a whole bunch of columns here for precipitation. Oh shit, we don't need those, right? Because they're not related to energy. So a decision made by the energy engineers 30 years ago about the data. They could have pulled all that data and put it in the weather file, but they thought it's not related to energy. So now we can't use those files because they lack water information, which is exactly what you need to run them for a WIFI analysis. So the disconnect between how energy and moisture works is a legacy in our industry. Now, having said that, I think we need to wrap up as to how and why and when should we do modeling.
Go ahead, Jake.
Yeah, I'm going to defer to Pete on this.
Well, I think if you're going to do the modeling, you better really understand the information that it can and can't provide. You better make sure that you do sensitivity analysis so you have more faith that that model is responding to the things that are important in this particular situation. And the last thing is, we've got to have a constant feedback loop of what really happened in that building. I think all rating programs that use the modeling should say we need at least 1 year of data before we're going to bless this.
Before we certify.
Yeah,
the
because
problem
you
with
need
that is who pays for that,
Well,
right? I mean, if we were doing a 2,000 square foot passive house, we're probably on the order of plus 10K to get modeling and passive house certification, right? On that house, a zero energy PV array is probably less than 30K, somewhere 25, 30K. With the 30% tax incentive plus the 10 grand for that, I could almost get that house to zero energy by not certifying it, right? And that's a hard one. When people, it's really interesting. People want to talk about return on investment until we want to have this conversation, right? Because now all of a sudden I could tell my clients, don't do that. Just take that money. We'll get close enough. And you know what? Who cares? If we don't get 0.6 and we get 0.71, who cares? Put a PV array on, take it to zero energy. We'll pay. We'll get those extra 1,000 BTUs in the year from the sun.
Yeah. Well, I think what I'm going to say is I don't want to get into a debate about how cost effective it is to wait a year for the data. But I think that at some level, we have to use that information to inform the modeling. But the other thing I wanted to say is that if the modeling gives you constant improvement on the way that you understand how buildings work, then that's a really good thing. For instance, there's an educational version of WIFI that ORNL gives out for free. It gives horrible results because it's not a fully blown tool. But if you want to learn building science at a quantitative level, there is no better
you can compare
tool.
this assembly to that assembly and understand this one is more likely to fail for these reasons.
Yeah, so it helps us better understand buildings.
Yes.
I'm all for it.
Me
but
too.
if you use it in the real world to think that you're going to come out with that result, that to me is a stretch.
Yes.
All right, before we wrap up, I want to ask Pete, because I don't think he's told this story on the podcast. I want to ask Pete to tell a story about moist. Do you remember this story?
Wow, this is a great way to end this up.
No.
So
it's a modeling story, right?
I had just started the NHB Research Center. I was in my mid-30s.
Dang.
I didn't really know much
So this
about...
is like 42, 41?
Thank you, Steve. We need to get over that hump with that joke. But so
We're almost there.
Doug Burch was a building scientist at NIST, the National Institute for Standards and Technology. And he was a really cool guy. He was a real nerd. And he said, hey, if you're trying to figure out the moisture performance of isonine, because that was one of the projects I was working on, you need to learn the program Moist. And so it was a kludgy program. It was before we had Woofy, but it was what people used. So that program, I got a disk, and it would come up, and it required a lot of computing capacity. So I didn't have a computer in my section that I was working in. I had to go to another division where there was a whole separate group of researchers, and use this particular computer that was in a little corner. But I used to come in and do it very early in the morning because that was when I knew I could do several runs. So I didn't know the secretary for that division, but she would come in behind me and she'd see I was working on the modeling program, and then she would go on her merry way. Well, this happened for about a week, and I went into the one morning, and Liza Bowles, who's the president of the organization, says, hey, Peter, my office. I thought, oh, wow. So I go in her office, and she goes, had a complaint about what you're doing here at work. And I thought, holy smokes. And then she's trying to keep from laughing. He said, so what have you been doing when you come in early in the morning? And I said, oh, geez, Liza, I've been using a computer that's not in my division. And now she's really trying to keep from cracking up. And she said, oh, and what are you doing on that program? I said, well, I'm running a moisture modeling program. Oh, well, when you open up the moisture modeling program, Doug Burch had programmed in the words on a black background in very alluring colors to say, moist, moist, moist. And the secretary had thought I was doing something related to pornography.
Content.
So Liza at that point is shaking. She's crying. She's laughing so hard. She said, I think what you need to do is come to the company meeting and explain what you're
Moist
doing
is,
with Moist, because that secretary thought
He
you were.
moisted up somebody's computer, somebody else's computer.
I mean, I went from really scared to
Uncomfortable?
the most fun was
You do have a real pervert look about you, I guess, maybe.
the most important part of the story is going back and telling Doug Burch, because he said, oh man, you just made my day as a nerd, that somebody thought it was something alluring. With that, maybe it's an appropriate way to end it.
Yes, it
No,
is.
I want to tell you about my little story here.
Okay.
Okay.
I took my wife to the theater to go see this performance. It was really, really cool. It was all about puns. I guess you could say it was a play on words.
Nice.
I'll clap for that one.
Nice.
That was a good one.
I don't know where you get these, but I'm impressed. Jake, take us home. Take us somewhere.
Yeah, take us somewhere. If you have questions or comments, questions at the unbuilditpodcast.com. That's our email address. We enjoy that form of communication with you. We also enjoy the fact that you are here listening or watching. And we are now available on Build Show Network as well. So if you go to buildshownetwork.com, you can find our catalog of podcasts there as well. That's new for us, or relatively new for us at this point, and we're happy that they have us. Till next time, gentlemen, thank you.
See y'all.
Have a good day.
So long.